when we're doing factoring by grouping, we want to look for parts of the polynomial that have a greatest common factor. And we can reorganize them if we need to, but sometimes they're usually just kind of already set up the way we want them to. So in this case, if I have 5n cubed minus 10n squared plus 3n minus 6, if I start by factoring, if I look at this first group, 5n cubed minus 10n squared, we can factor 5n squared from that group. So when I factor that out, that's going to leave me with n minus 2. If I look at my other group, 3n minus 6, we can factor out a 3. So that's going to be plus 3 times the quantity, n minus 2. And all that's equal to 0. So now when I continue making this, all right, I can see that I have n minus 2 in both of those terms that we factored from. We've gotten the greatest common factor. So that means I can factor out an n minus 2. That becomes our new greatest common factor. And what's remaining is 5n squared plus 3 is equal to 0. So now I can go ahead and set my two factors using zero product property, set it each equal to 0. So n minus 2 equals 0, so that means that n is equal to 2. 5n squared plus 3 equals 0. So I've got 5n squared equals negative 3. N squared is equal to negative 3/5, which means that n is equal to plus or minus the square root of negative 3/5. Well, let's go ahead and simplify and rationalize that. So I'm just going to ignore the plus or minus for the time being, and I'll do that over here. So I've got the square root, I square root of 3 over the square root of 5. So that means we're going to multiply numerator and denominator by square root of 5. All right, so root 5 times root 5, that's going to be 5. Root 3 times root 5 is root 15. Nothing we can simplify there. So I've got I root 5 divided by 15. So that means that our solution set is going to be n is equal to 2 or plus or minus I root 15 divided by 5.